We are going to review question 21 of 1985 AMC8. Mr. Green receives a 10% raise every year. His salary after 4 such raises has gone up by what percentage? We are going to assume that Mr. Green's salary is 100. So a raise of 10% will bring it to 110 in the first year and 121 in the second year, 133.1 in the third year, and in the fourth year, end of fourth year, it's going to be 146.41. This can also be calculated like 100 plus 1.1, increase of 10% over 1 to the power 4, which will give you the same answer. Now, when we subtract 100 from 146.41, we get around 46.41, which is more than 45%, and that's your answer. Moving to the next question. Assume every 7-digit whole number is a possible telephone number, okay, except those that begin with 0 or 1. What fraction of telephone numbers begin with 9 and end with 0? Okay, so first we need to find the denominator in this problem, which is the total telephone numbers that we can actually have. Because it's a 7-digit number, we are going to put 7 dashes here, and for each of the 7 dashes, we are going to see the possible numbers that we can enter. So in the first dash, we have a possibility of entering 8 numbers, 8 single digit numbers, excluding 0 and 1, right? So that is why 8. So if you could enter any number, it will be 10. If you are entering, you cannot enter 0 or 9. So you can enter possible 8 numbers. For rest of the dashes, we can enter any of the 10 numbers between 0 to 9, right? So multiplying these possibilities, we get 8 followed by 6 zeros. So these are the total number of telephone numbers that can exist, and this becomes your denominator. Now for the numerator, we know that numbers should begin with a 9 and end with a 0. So going by the same logic, there is only one possibility of 9 in the first dash and a one single possibility of 0 in the last dash. The rest of the dashes can have any of the possible 10 digits. So this makes a total of 1 followed by 5 zeros, and this becomes your numerator. So your final fraction will be 1 followed by 5 zeros divided by 8 followed by 6 zeros, which will give you an answer of 1 by 80. This is the fraction of telephone numbers which begin with a 9 and end with a 0. This is a combinatorics problem which you can solve using simple logic, simple counting methods. Going to the next one. King Middle School has 1200 students. Each student takes 5 classes a day. Each teacher teaches 4 classes. Each class has 30 students and 1 teacher. How many teachers are there in King Middle School? You have to be very careful about avoiding double counting in such problems. So we are going to divide this problem into two perspectives. One is the student perspective, the other is the teacher perspective. And what we need to calculate is the student classes. Okay. So for every student, the total number of classes he takes is there are 1200 students multiplied by 5 classes a day. So totally the student classes are 6000 in a day, right? So the total students taking the total number of classes will become 6000 student classes in a day. Now from a teacher's perspective, we have 4 classes and we have 30 students per class. 4 classes taken by each teacher. Okay, so multiply this, you're going to get 120 student classes from a teacher's perspective. Now to find the number of teachers, we need to divide this 6000 by this 120, which will give you 50, and this gives you the number of teachers, and E option 50 is your answer. Going to the next one. Question 24. In a magic triangle, each of the 6 whole numbers 10 to 15 is placed in one of the circles so that the sum S of the 3 numbers on each side of the triangle is the same, the largest possible value for S. So we have to find the largest possible value of S. Now what is S here? S is the total of A, B, C. S is also the total of C, D, E, and S is also the total of E, F, and A, right? And all these are equal. It is the same S in all the cases. So S is the same as A plus B plus C, which is the same as C plus E plus D, and which is the same as E plus F plus A. This also can be written as 2A plus 2C plus 2E plus B, D, and F divided by 3. So that is what is S. Okay. Now, if we want to maximize the value of s, okay, anything which we are going to double, so these three numbers should be the highest numbers, then only the value of s is going to be largest. So we are writing here 2 into 15 plus 14 plus 13. So basically what are we doing? We are having the greatest numbers in the corners, because the corner ones are the numbers which are going to get counted twice, right? So we say 2 into 15 plus 14 plus 13, which are basically highest numbers, and then the other numbers are going to be counted only once, 10, 11 and 12, which will come in the middle, these three numbers. So this divided by 3, which is giving you a total of 84 plus 33 by 3, and which will on simplification come to the value 39, which is D, and that's your answer. Now moving to the next question. 5 cards are lying on a table as shown. Each card has a letter on one side and a whole number on the other side. Jane said, if a vowel is on one side of any card, then an even number is on the other side. Mary assured Jane was wrong by turning over only one card. Which card did Mary turn over? Now, this type of card turning problem is a very popular trick called the Watson selection trick. Okay, so this you can Google, and this is going to guide you in solving this problem. But as of now, let's come back to this. Now, what does Jane say? She says if a vowel is on one side of any card, then an even number is on the other side. So I have to prove this statement wrong, right? So then what I need to do is I have to check a vowel. Okay, if I open a vowel, then there should be a odd number on the other side. That is what makes this statement wrong. Correct? But do I have a vowel here to open? I don't. Okay. What is the other way I can look at it? If I open an odd number, then if there is a vowel behind, right? Then what should happen? Then also her statement is proved wrong, isn't it? So do I have an odd number here? Right. I have only one card which has an odd number here, which is 3. Okay. So if I open 3 and if there is a vowel behind 3, then we can automatically prove that Mary's statement is wrong. Sorry, Jane's statement is wrong. Okay. So this is the card that we need to open. Answer option A, 3.